Welcome to Architect Tips, presented by ClearMeasure, a software architecture company empowering .NET development teams to be self-sufficient, able to move fast, deliver quality, and run their software systems with confidence. Make sure to subscribe on YouTube or your video podcast feed. If you have a question for the show, send them to architecttips@clear-measure.com, and the next tip could be yours.
Welcome to Architect Tips with a tip so that you can get your team to move faster and deliver quality and run your system with confidence. We're going to talk about architecture of Blazor today and some of the key differences if you are running a Blazor application. And so let's dig right into it. Before we do that, you might want to check out Azure DevOps Podcast. It is for .NET developers who are shipping software with Microsoft platform technologies. You can go to www.azuredevops.show. Now, Blazor is a different architecture. It's a new architecture, came out with Blazor server side last November. It runs on top of .NET Core, and the server side has been out for a number of months. WebAssembly just came out in May, and people are trying to figure that out. However, there's lots and lots of applications being developed already with the Blazor server-side model. And I want you to understand the key differences in that model from regular web applications so that you can be successful with that. So what's important to understand is that Blazor runs on top of ASP.NET Core. So startup, the middleware, all that stuff, running it in Azure is all going to be the same. It's going to run in process, but the Razor components are a different programming model in the UI that's different from your ASP.NET MVC controllers or Web API controllers. And it is a stateful programming model. So when a Razor component essentially paints a screen, that class is going to be in memory. It's going to be on the call stack in memory for the entire time that your user has that screen open in their browser. And what happens is when you have that first request to your URL, your web server is going to return back a JavaScript file. And that JavaScript contains the Blazor client, and it's canned. You don't even need to mess with that. But the client is going to subscribe to a built-in SignalR connection back run by your web application automatically. Blazor publishes a SignalR hub, and every bit of communication between the browser and the server is going to go across that SignalR hub. Now, if you're hosting it in Azure, you're going to want to use the Azure SignalR service because that is really scalable and is going to take that processing power off of your web instance. Okay, but it's important to understand what happens, and that Razor component class is going to be on the call stack and it's going to be alive in memory. That instance of the class, the entire time that screen is on the page, no matter how many times things are clicked, no matter how many times maybe a section of the page is swapped out, that is going to be on the call stack. Now, if you do a navigate URL to another top level page, well, then it'll go out of memory and be cleaned up. That's how Blazor server side works. And so every session, every user's screen and what a user is doing is resident in memory on your web server, and the changes to the screen are messaged through that SignalR hub with binary messages. So what's really important is latency in the network connection. If you have really bad latency, then your users are going to see slowness because, for instance, if you have 100 millisecond latency, which is really bad, but you need maybe 10 round trips to the server, which is not unheard of. These messages are really small, but if it's 100 milliseconds of latency with each one, well, that's 1 second. So you got to keep that in mind. That is the architecture. Okay. Now, let's go over some of the settings when you're publishing it to Azure. You are going to want to make sure that you choose 64-bit because you are going to be using up more memory because every one of your agents, every one of your users is keeping that memory on the server, and their session and everything that they do and all of the memory is keeping those objects on the web server. So you will be using more memory as a trade-off for that phenomenally fast development model. You can crank out applications so quickly. It's so much more productive than JavaScript and the JavaScript ecosystem. Now, you will want to turn on WebSockets. Off by default, you need to turn on WebSockets. We do rely on SignalR and the custom built-in SignalR hub. If you leave that off, SignalR is going to fall back to long polling, which is going to send a lot of requests to IIS. You'll be able to see that in application insights, that your application is not doing anything, but you're getting a ton of requests. That's a tip off that maybe you don't have WebSockets. And you can also press F12 in the browser tools and make sure that you've connected to your WSS protocol for the WebSocket. You also want to have ARR affinity, because we keep around in memory objects for a user session. You want to make sure that essentially you're turning on sticky sessions. The first request comes in, a user is going to be assigned by the load balancer to one of your web instances, and that user is going to use that web server instance the whole time that they have the tab open for that session. They may be assigned to a different one if they close the browser tab and come back, and essentially recreate everything from scratch, but you'll be on one web instance. Okay. Also, you want to learn kind of how Blazor server side interacts with the browser, because all of the data, everything to show on the screen is going to be coming through binary messages on a SignalR circuit, and then that JavaScript client, that is the Blazor JavaScript client that's running in the browser, is going to take that information and append children to the DOM in the browser. And so you can inspect all the different frames that are coming just by looking at the performance tab in the Chrome developer tools. And it's really important that you kind of understand how many frames are necessary per page, because if you have a ton, it is going to make for a slow page. So you want to use that as a point of optimization. Also, you will probably want to look at how many round trips your application is making to the server. You can go to the network tab in the tools, and you can click on the WebAssembly connection, sorry, not the WebSocket connection, and you can see all these different binary messages. If you select one, you can kind of see what it's doing. Every stage, every method that's called is kind of a round trip. So we can see the on render completed right here, and I've kind of zoomed in on the bottom, but you'll want to inspect that and understand what your message is doing with these binary messages. Now, the Canary version of Edge, the Chromium version of Edge, has some enhancements that are being worked on in the developer tools to show a visualizer of these binary messages, so that you can sniff the wire and you can see exactly what's coming through. Because right now, not very helpful to see the current views other than, hey, it came through and how big are these? But the tooling is definitely coming so that we can see exactly what's in these messages, because that'll be important. When you're running in Azure, you want to have a minimum of 2 web instances, because it uses sticky sessions. If something happens to that web instance, you want the web browser to immediately be able to take all of the connected sessions and move them to another instance of the web server. And with the auto reconnect behavior that Blazor has in the JavaScript client, that can happen automatically for you, as long as you have that second web server that those users can be assigned to. Okay. And I hope that helps. And if you are starting a Blazor project, let us help you avoid those pitfalls. ClearMeasure is a software architecture company that really wants to help your development team move fast and deliver quality and run your systems with confidence, so that you can get more done internally within your team and deliver world-class results. So thank you very much. And that was another Architect Tip.
Thanks for watching Architect Tips. If you would like help improving your team's speed, quality, or software stability, send us a note to architecttips@clear-measure.com. On behalf of everyone at ClearMeasure, thanks for watching, and may God bless you.